Hey, what's up? Back for lesson number 2 in Unit 7. This time we're talking about arithmetic and geometric means. You'll see what that means in a second. But let's see. When we're working with or reading a sequence, that's supposed to say we have nth terms. An nth term is just a specific term within a sequence. So like maybe you wanted to know the 15th term in a sequence, but you only know the first couple. Right? You still might be curious about what that number is. So this is how we're going to be writing our sequences out for the most part, right? We're going to have these little fancy brackets. Again, do your best with writing little fancy brackets. If you have to use the square ones, I understand. But we write them in a very different way, right? We have big A would be the number itself, and then this would be the position that it's in, the nth position, the nth term. This n plus 1 means that this would be the next term in sequence, right? Because this would be, let's say, number 5. This would be 5 plus 1 would be number 6. This would be number 7. But then depending on what our series or our sequence happens to be, common difference or common ratio, right? We would have different big A values, okay? That's all that means. That's how you read these. So we might have an arithmetic sequence such as this, right? We might have 30, then 36, then 42, then 48. That would mean that they're in the A1, A2, A3, and A4 positions. Okay? So we might have a sequence, and we might not know a term later on. Right? Like I said, we might know the 4th, but maybe we want to know like the 15th. So real life example of this. Let's say that you have $30 in your savings account right now. Right now in your account, that's what you have. Maybe it's your piggy bank. Whatever. But every week you're able to save and deposit into that savings $6 more. So you start with $30 this week. The next week you have $36. The next week you put another $6, you're up to $42. So if there's a concert that you want to go to and it costs $108, but it's in the next 4 months, 16 weeks, will you have enough money saved up by then? So if this is the case where you're adding $6 each time to that little piggy bank, how much or what number will you have right here at week 16? That would be the nth term, the 16th term. Okay, but we have a formula for that. And this is where I really enjoy this kind of math. It's a very simple formula, and you can impress people if you remember this formula, because you can be like, look, I can tell you what the next number is in the sequence. So here it is, right here. This is your formula. Make sure you write this down. Okay, if we want to know the nth term, like for example, if we want to know the 16th term, this is the number that we're trying to figure out. We start with the first term in that particular sequence, right? In this example, we would have 30 plus the number minus 1, that same n that you're trying to find. In the example from up here, we're trying to find 16, so we would be plugging in 16 right here minus 1. So the number that would end up being in here would be a 15. And then finally, the common difference. This problem told you we're adding $6 every time, every week. So the common difference here would be 6. We still might have to do that quick subtraction that we did last lesson to figure that out, but no big deal. So that's where all these numbers are coming from. Your first term, common difference, and then whatever term you're trying to get to minus 1. So let's solve that problem, that real life situation problem. Right, if we start with 30 and we go to 36 and 42, 48, and we want to look for A16 using this formula. So, oops, we'll make that into A sub 16, because that's the one that we're trying to find, A sub 16. It's going to be equal to A1, which is 30, plus N, which is 16, minus 1, times D, the common difference. Well, I'm going to do it real quick just to show you, but 48 minus 42 gives us a common difference of 6. Now, really, we should make sure that that's a common difference for each of these, but I'm going to tell you for this lesson, I'm not going to be throwing out sequences that aren't arithmetic for you to use, because the title of this said arithmetic means, so we're going to assume that it works the whole way through. Okay, so we're going to simplify quite a bit of this. 16 minus 1 is 15 times 6. Again, if you have a calculator handy, this makes your life a little bit easier. 15 times 6 is 90, plus 30 is 120. So the question earlier on the last page was, will you have enough money in the 16th week if you save $6 every week? Yeah, you have enough money. You have $120 saved up. It's only $108 for that concert, so you definitely made it. You have $12 to spend on like a burger or something before the show. Alright, so we're going to do a couple more problems. They're going to look much more this way in the future. I'm going to do these first two, and then I'll scroll down so you can see the bottom two. But they're going to give you a little bit of information. They're going to tell you what number term you're looking for, and they give you a couple of numbers in that particular sequence. So, this first problem, they give us 26, 19, and 12. And they want us to find the 12th term. So let's go find the common difference. 12 minus 19, that's negative 7. So our D value is negative 7. Our A1 is 26, N is 12. So if we're trying to figure out the 12th term, we need 26 plus 12 minus 1 times negative 7. 12 minus 1 is 11. 11 times negative 7 is negative 77. 26 minus 77, we're going to get negative 51. So the 12th term, if we continue to subtract 7 along the way, will get us negative 51. This is not as impressive with lower numbers, right? We want to know maybe much farther along numbers like the 50th term. We might not want to sit there trying to add or subtract 7 every time, right? Because, yeah, could you sit here with a calculator and subtract 7 a whole bunch of times? Yeah, you could, but this is a much faster way of doing it. So, especially when we have much higher up numbers like 50th term. So we want to find the 50th term. Well, we need our D value, so we're going to start by figuring out that. 412 minus 365 we get 47. I'm just going to make sure I didn't mess up my math here. Yeah, we're good. 47. So our D value, our N value is 50. A1 is 318. So 318 plus 50 minus 1 times 47. 50 minus 1 is 49 times 47. 49 times 47 is 2,303 plus 318. Final answer, 2,621. So the 50th term is 2,621. Would you really want to sit there with a calculator adding 47, a whole bunch of times to this number? And then what if you lose count? What if you accidentally do it too many times or not enough? You don't want to take that risk. Just use the formula. So you got two problems to try out right here. Yes, there's a fraction. Don't let the fractions bother you. You can use a calculator. Pause the video and resume when you're ready to check both of these. All right, let's see. We want to find the 21st term. We need to find our common difference first. So 191 minus 106 is 85. So that's our common difference is 85. And is 21. First term is 21 as well. So let's see. We want to find the 21st term. That's going to be 21 plus 21 minus 1 times 85. 21 minus 1 is 20 times 85. 20 times 85 1,700 plus 21, 1,721. Not bad, right? Use the formula, everything goes smoothly for you, right? Plus, I mean, really, if you get to this point right here, this is enough where you could type this directly into the calculator. I need to see at least this on your work so I know what numbers you meant to plug in. You can probably skip from here directly to here. I'm okay with that, but again, make sure that you show me and be careful if you're going to type it into the calculator that way. So your other you try problem, let's figure out 7/5 minus 4/5 is 3/5, 3 over 5. So that's our common difference. So if we want to find the 8th term, we're going to start with 1/5. Common difference is, 8 rather, minus 1 times common difference of 3 over 5. Let's see, that's really over 1. So 1/5 plus 7 times 3 is 21. 1 times 5 stays as 5. 1 plus 21, 22/5. Again, you could have used the calculator at this point. It would have been kind of messy to type in, but it's doable. Hopefully you got 22 over 5 for that problem as well. So you can see, pretty easy stuff. Now you might be saying, all right, well, that's all great and everything, but what if we wanted to generate a function specific to a sequence, like that one that we just looked at, that would give us any number in that sequence just by plugging in or evaluating the number position we're looking for? Can we do that? Right, that would make our life even easier because we wouldn't have to do that formula every single time, right? We could just say, all right, what if I want the 50th term? Boom, plug in 50. What if I want the 100th term? Boom, plug in 100. That'd be a lot easier. Well, yeah, we can definitely do that. Right? Like, what if we knew our first number was 31 with a common difference of 13? Can we make a function that would give us the 17th and the 23rd and the 100th term? Can we do that? Yes. Yes, we can. So here's what we're going to do. We're not going to do this exact one. We're going to do a couple of examples down here. Actually, no, we're not. We're going to do this one. Let's do this one out. Let's figure it out. All right, so we want to find an in function notation. So this is how it's going to look. So this is what we're going to do. Get a pen here. We're going to try to figure out what the function looks like for this particular problem. Now, we have an that we don't know, and that's what we're trying to solve for. But we do know our first term is 31. And again, we don't know the number term that we're looking for, so we're going to leave this as n minus 1. But we do know the common difference as 13. So if you think about it, there's only one variable here that we're looking for. So if I can simplify this expression, then anytime I plug in an n, if we evaluate that, that'll give us the nth term. So how do I simplify this? Distribution. 13 times n would give us plus 13n. 13 times negative 1 is minus 13. So our function here, I can combine like terms, so 13n will stay in front. 31 minus 13 is, nope, that was the wrong button. 31 minus 13 is 18. So here's our function. Doesn't matter what number we want to find in this sequence. If I plug in 1, I'm going to get the first number out. If I plug in 13 or 17, right? If I plug in 17, I'll get some number out. So let's figure out what number we would get. So 13 times 17 plus 18, we would get 239 for the 17th position. What if we wanted to find the 23rd position? 13 times 23 plus 18. 317. Way faster now, right? And again, we could find the 100th term. I'm going to skip doing that one for right now, but you get the idea of how that would work. So we got a couple more to try out here. Okay. It says write in function notation and find the value of n. So we've got to write this in function notation, which looks like this for this particular function, and then we're going to evaluate 13. So this is what we started with. We said we don't know what term we're trying to find yet. But we do know our first term. Again, we don't know what n is, but it's still going to be -1, and they gave us a common difference. We're just going to do whatever we can, right? This is the only thing we can do, is distribute. So -52 times n would be -52n. -52 times -1 becomes +52. So here's your function. -52n, I'm going to put first, and then I can combine 43 plus 52. So here's our function. That's one of the things they asked us for. Now, if we want to know the 13th term, a sub 13, -52 times 13 plus 95. So let's see, -52 times 13 plus plus 95 rather. I got -581. And that makes sense because if we start at 43 and we start subtracting 52, we're getting into the negatives pretty quickly. So second example here. Again, we're going to start with a sub n equaling 208. We don't know what n is. D they gave us as 41. Distribute. (41n minus 41). Rearrange a little bit. We'll put 41n in front. 208 minus 41 is 167. So there's the function that they wanted, and they want us to evaluate at 8. So 41 times 8 plus 167 is going to be 495. So as you can see, you can figure out any number anywhere you want in that particular sequence very fast, especially if you have a calculator, but very fast. And you can pick out whatever numbers you want. No more needing to count or to press buttons on the calculator more than you need to. So here's one for you to try out. Pause the video and resume it when you're ready to check. Alright, let's see how this one went for you. You're going to do a sub n equals 87 plus n minus 1 times 19. And you should know to distribute to start. And then finally, rearrange and combine like terms. So 19n will come first. 87 minus 19 is 68. So here's your function. Now they want you to evaluate 25. So the 25th number in that sequence . 19 times 25 plus 68 is 543. Hope you came up with that number. Pretty easy lesson, much shorter than the last lesson, only 20 minutes on this one. I'm pretty sure that's it. Let me just make sure. Yeah, we're not all done with this lesson, unfortunately. I'm sorry about that. We're all done with arithmetic. So here's what I'm going to say. This is already a pretty long lesson. So if you want to pause it from here and then resume a little bit later to get the rest of the notes, that's fine. But I'm going to keep on trucking through with this one. Now we've got geometric. Good news is this is the last page, though. So geometric sequences behave the same way, and they have their own formula. So here's your formula for geometric sequences. Right, so if we want to know the nth term, we're going to look at the first term times the common ratio to the power of n minus 1. The n minus 1 shows up quite frequently. It's because it's not, we don't usually consider it like the first term to be 1. We consider it to be n. So that's why that minus 1 part happens to be there. So if we want to find the fifth term in this particular sequence, it's basically the same idea as before. We're going to figure out the common ratio. Now we can see it's not arithmetic, so this should be geometric. Let's just make sure of what a common ratio is. 144 divided by 36. That gives us 4. And that's going to be the same between these. Again, I'm telling you that they're going to work for these particular problems. I'm not going to throw out a non-geometric on you. So we found our common ratio of 4. We want to find the fifth term. So a sub 5 is going to equal our first term 9 times our common ratio of 4 to the n, which is 5 minus 1 power. 5 minus 1 is 4. So this I can type right into my calculator, but I'm going to be careful about it. In fact, I'll show you on the screen. Okay, 9 times 4 to the 4th power. So the way that it's on my screen right here matches exactly with how I have it right here. And we get 2,304. Okay, very similar problem right here using the same formula. So I got to figure out our R value first. So if I do 1/3 divided by 1/9, again, the calculator makes this a little bit easier. We get 3. So they want to know the 13th term. Our first term, 1/27, times the R value of 3 to 13 minus 1 power, which is the 12th power. So I'll put it right here. Right, we have 1/27 times 3 to the 12th power. 19,683. By the way, I'm using the school calculators, the TI-84s, but if you use Desmos, it'll still do all this stuff for you. It's just Desmos, as far as I know, doesn't have the fraction converter for you, so this is just a slight advantage with the TI-84. So here you go. You've got one to try out right here. Hopefully you have that formula written down. Pause the video and resume when you're ready to check. Alright, so let's see. -50 divided by 10 is -5, so our R value is -5. We want to find the 9th term. So a sub 9 equals -2 times -5 to the 9 minus 1 power, which is really to the 8th power. Now notice how I put parentheses around my -5. I've got to make sure I do that when I type it in too. -2 times parentheses -5 to the 8th power. -7, 8, 1, 2, 5, 0. If you didn't put parentheses around the 5 when you do that, it's going to end up making it become a positive number. Maybe it would end up still being a negative number, but we got to be careful. Depending on what number is in front here, this could definitely change if we don't have parentheses in front. So just be careful with that. All right, so we've got only a couple more left to do. I think it's 4 left to do. Okay, they're asking us to write these geometric functions in function notation. I'm sorry, sequences in function notation. Pretty easy to do. Okay, we already know what the formula looks like from before. We already know our first term. We just have to figure out our R value. That's it. Just figure out the R value. And that's easy to do. It's just division. Right, so we're going to do 153 divided by 459. Math frac enter gives us 1/3. Now that we have the R value, we have everything we need. A sub n equals A sub 1, 1,377, times the R value to the n minus 1 power. Right, there's nothing for us to simplify here because we don't know what that exponent's going to be until we plug in. So that was pretty quick and easy. I'm going to do one more for you, and then you'll have 2 to do on your own. Okay, so again, all we had to do is figure out the R value. So actually, I'm going to use the easier numbers. We'll do 216 divided by 12. And I got 18 for that one. So A sub n equals A sub 1, which is 12, times 18 to the n minus 1 power. That is the function notation of that particular sequence. So you've got 2 to do on your own. Super easy. Last couple ones for this lesson. Pause and resume when you're ready to check both. All right, so let's see. R value. That's the work that you're doing here. So 108 divided by negative 18 is negative 6. So that's our R value. So A sub n equals 3, our first term, times negative 6 to the n minus 1 power. If you didn't have those parentheses there, you need them, please make sure you include them. Your last problem here, 8 over 45 divided by 4 over 15. I'm going to do that one on the calculator. Math frac enter gives me 2/3. So A sub n equals our first term is 2 over 5 times 2/3 is our R value to the n minus 1 power. Alright, so I know I gave you a false end of the lesson a few minutes ago. This is the end of the lesson. This is the last page here. Pretty easy stuff, especially the geometric sequences. Very easy, especially if you remember these formulas, right? So practice this stuff. See how you do with the homework. Leave questions if you need to, or bring them in with you to class. Either way, I'll see you on the next lesson. Bye.